This is the 10th in a series of video-based lessons that will describe the process of translating business requirement into an initial entity relationship diagram for a data model of moderate difficulty. In this video recording, we will introduce moderately complex water utility data model. This example's narrative, spread over several slides, will serve as a basis for our data modeling process, and we will keep referring back to it. In this presentation, we will go through the first two stages of DM process. 1. Identifying entities and their primary keys, as well as attributes, and 2. Adding relationships between those entities, ending with an initial ERD. This material is covered in the first part of Chapter 6 in the textbook. As you know from your first Intro MIS class, the process of gathering and analyzing business requirements is one of the initial steps in the Systems Development Life Cycle, or SDLC, and is just as much an art as it is science. The key is to stay as organized as possible when talking to users, management, and other key stakeholders. Their input, either through interviews or meetings, will sometimes be very precise and informative, and other times ambiguous and downright confusing. It is your job to navigate the lack of clarity and structure in these situations. Some of the same themes around business processes will get repeated often and will emerge as something you can hold on to. You will have to eliminate the irrelevant stuff and perhaps add some missing pieces later. Eventually, a data model will emerge that will provide a relatively standardized vocabulary around the various business processes. It will enable the organization to clarify and enforce business rules, assure high data quality and consistency, and derive a number of intangible benefits beyond just having a transactional database system in place, as critical as that is. As you convert the requirements into an ERD design, you need to make sure the ERD is consistent with what you heard from the stakeholders, and that it is, at least initially, as simple as possible. We already mentioned the first two steps of our DM process. 1. Identifying entities and primary keys, and 2. Adding relationships between entities. These two ERD building blocks will emerge from the initial pass through the narrative describing and analyzing business requirements. We will need to periodically go back to the narrative to revise and refine the initial ERD, perform both design and diagram error checking until we end up with a final ERD, which will then manually convert into RDBMS tables using SQL's create table command. In that sense, we will be coming back full circle to the beginning of the class when we use the same SQL statement to create our simple sporting goods database. This and the following 3 slides describe business requirements for the water utility database, the Chapter 6 case. I will more or less read through these 4 slides and then keep coming back to them as we go through the various stages of DM process. So, the 2 major functions of the water utility database are recording of customers' water usage, reading those recordings, and then billing for it based on the rates approved by a public water utility commission. In order to do that, the database should contain data about customers that use the water, meters that record the water usage, readings that periodically read the recording water usage, approved rates applicable to different types of customers, and bills that use the readings to calculate the amount owed by customers for water usage in a certain time period. Starting at the beginning of last sentence, we need data about the customers to include the unique customer number, first and last name, address, residential or commercial type, applicable rate, and 1 or more meters. Notice that the reference to meters is actually a relationship rather than an attribute. One customer can have 1 or more meters. Presumably, commercial customers are those with multiple meters at several facilities. The meters themselves include a unique meter number. This number is engraved / stamped on it right before it is put to use. This implies, a bit strangely, that the meters not in use do not have a unique number and are not being accounted for in the database. This is not likely, and we'll come back to this ambiguity in the next video recording. Other meter attributes include an address where a meter is being or is about to be used, its size and model. The fact that a meter is associated with one customer at a time describes cardinalities in the relationship between meters and customers. A reading is performed periodically by an employee who becomes, at least initially, an attribute of those readings. A meter reading document that is automatically created by some kind of reading mechanism contains a unique meter reading number, an employee number, and a meter number. So 3 identification numbers in all. In addition to these 3 numbers, a time stamp is automatically generated and the water consumption level read, which is sort of the whole point. Initially, a meter that was just placed in service does not have any readings associated with it, which will help with cardinalities of the relationship between meters and readings. Rates are characterized by unique rate numbers, each of which describes a different set of parameters associated with that particular consumption rate. These parameters are description, a fixed dollar amount applicable below the given water consumption threshold, and the variable dollar amount that is quoted per cubic foot of water consumed. The rates are designed, or assigned I should say, based on customer type. Residential rates are typically lower than commercial. Address for distance from pumping substations is needed, and other adjustments factors are there, all of which are within the purview of the state's Water Utility Commission. The fact that many customers, especially residential customers in the same neighborhood, can be assigned the same rate describes one aspect of cardinality between customer and rate. The fact that the rates are proposed by the water utility and approved by the State Commission well in advance of being attached to a particular customer will also help with the cardinality between rates and customers. The bills are a bit trickier than they appear. The bill is contingent on a recent meter reading, so its relationship to readings is as critical as its relationship to customers. Without readings, the bill could not calculate the water consumption and use customers' rate to calculate the amount owed. The structure of the bill is described on this slide, with a heading that contains unique bill number, customer number, and a set of dates. Each detail contains the meter number, the water consumption level calculated from 2 subsequent readings, and the amount owed. It seems that additional detail lines refer to different meters with their consumption levels and amounts owed. This is something that should be clarified with the billing department, but it seems like a reasonable assumption. At this point, I'm going to take a pause.